Okay, kids, welcome to your first remote lesson. So we're basically going to be flipping the class this week. So I'm going to be teaching you through these video lessons. You'll have the homework on the next day as usual, but I'm going to expect you to take notes on these so you can refer back to them. So the first example in multiplication of polynomial functions is if f of x equals 2x to the fourth and g of x equals negative 5x to the third, find fg of x. Now when you have the two names of the functions put together like this without a plus or a minus in between, it means we're multiplying them. So essentially you're going to take 2x to the fourth and multiply it times negative 5x to the third. Okay, and this would be f of g of x. Now what we want to do here is to simplify this. Okay, we have numbers in two different places and we have x's in two different places. So we are going to multiply the numbers together and then multiply the x's together. So 2 times negative 5 would be negative 10 x to the fourth times x to the third. If you do that, when you are multiplying powers of the same base, you add the exponents. So this becomes negative 10 x to the power of 7. And that's going to be my answer for that problem. Okay, fairly simple. With our next example, it's going to be very similar. So we're going to say that f of x equals negative 4x to the fifth, g of x equals negative 3x to the fourth, and h of x equals negative x to the sixth. And we want to find f, g, h of x. Now the way we're going to do that is the same way we did up here. We're just going to multiply them all together. So negative 4x to the fifth times negative 3x to the fourth times negative x to the sixth. Now when there's more like this, sometimes it's a little bit easier to go ahead and rearrange them in a way that makes more sense. Usually what I will do is I will take all of the numbers and put them in one set of parentheses and take all the variables that are similar and put them in another set of parentheses. So for this set, I'm going to take negative 4, negative 3, and if you look here, there's a 1 in front of that, so we'll make that times negative 1. And then we're going to put all of my x's, x to the fifth, x to the fourth, and x to the sixth in another set of parentheses. Now the reason I do this, it's nothing terribly complicated, it's just because it helps me personally to keep track of everything. And so I'm going to continue down this road and say negative 4 times negative 3 times negative 1, in case you wanted to see that. Negative 4 times negative 3 times negative 1 is going to be negative 12. These are powers of the same base, so we are going to add the exponents. 5 plus 4 is 9. 9 plus 6 is 15. So negative 12x to the power of 15 is going to be the solution there. So that's a pretty simple one. And then technically we're not even multiplying polynomial functions yet. We're just multiplying monomials. So we're going to move on to the polynomial functions. Okay. So what we're going to do here is we're going to do two polynomial functions, or one monomial and one polynomial. So we're going to say if f of x equals negative 5x to the fourth and g of x equals 9 minus 2x squared plus 4x to the power of 3 minus 7x to the power of 4, find f, g of x. So the steps here are exactly the same as the steps we took before. Now the only difference is now we've got 4 things here. Now what I would do personally to make this easier for myself and to make it look better in the end is first of all to rearrange g of x. Typically if you have more than one term in an expression and they have the same variable but different exponents, you want to have the biggest exponent first and the smallest one last. So we're just going to rearrange this to put negative 7x to the fourth plus 4x to the third minus 2x squared plus 9. Now that's just going to help us out in the long run here. Now saying that, we have fg of x. F of x is negative 5x to the fourth times negative 7 x to the fourth plus 4x to the third minus 2x squared plus 9. Now this looks like a lot, and it kind of is, but really what it is it's a distribution problem. So we are going to distribute our terms the same we would with any other question. Okay? So we're going to multiply the first one times the first value here. It's not a very good marker. I'm going to keep with my green here. We're going to multiply those two. Now I'm going to do it the long way the first time, and then as we go along, hopefully you'll be able to catch on to the shortcuts. So f of g of x, the first term is going to be negative 5x to the fourth times negative 7x to the fourth. Okay? Okay, then after that, we are going to multiply the second set of terms. It's negative 5x to the fourth times 4x to the third. And the third set of terms, negative 5x to the fourth times negative 2x squared. And finally, the last set of terms, negative 5x to the fourth times 9. Whole bunch of stuff, but like I said, as we go along, we'll shorten this up a little bit and sort of do shortcuts to skip this particular step. But seeing as how it's the first time, we're going to show everything. So negative 5x to the fourth times negative 7x to the fourth. Negative 5 times negative 7 is positive 35. X to the fourth times x to the fourth is x to the 8th, because we add those exponents. Negative 5 times negative 4 is negative 20. Sorry, negative 5 times positive 4. And then x to the fourth times x to the third is x to the 7th. Negative 5 times negative 2 is positive 10. X to the fourth times x squared is x to the 6th. And then we have negative 5 times positive 9, which is negative 45. X does not have a partner, so it's going to stay x to the fourth. So here's the trick. What we're going to do is we are going to check our answer. Okay? And the way you're going to check your answer is using the calculator. Okay? So what you're going to do is you are going to take the original setup for the problem, okay, which is this, so you have to get this correct. This is going to go into y1 in the calculator. You are going to take what you think the answer is and put it into y2. So what that does is it's going to allow us to check and see if our values add up to the correct amount. So I'm going to go in here. I'm going to put into y1 exactly what I have here. Negative 5x to the fourth and then all of the other stuff. Negative 7x to the fourth plus 4x to the third minus 2x squared plus 9. Okay? Now, that's going to do a whole bunch of math for me. Now, what I want to see is it the same as the answer I found? Because if I multiply them together, I should get the same thing. Like if I had 2 plus 4 on the first line, and I put 6 on the second line, they should be the same, right? So I'm going to put in what I think my answer is. 35x to the power of 8 minus 20x to the power of 7 plus 10x to the power of 6 minus 45x to the power of 4. And press enter. Now the idea is that these two things should be the same. So when I go to my table, I should be able to look at the far two left or right hand columns, and they should be identical all the way down. And if you look, they are exactly the same. If they are exactly the same, that means that I have multiplied correctly. Now, this is going to come up a little bit later. We'll do this a bunch of times, maybe not every single time, but this is a way that you can check to make sure that you have multiplied correctly. Because if you put a negative sign where a positive should be, or the exponents aren't right, or you multiplied incorrectly, then these two columns will be different. Okay? But that only works if you set the problem up correctly first in the first place. Okay? Let's go ahead and take a look at our next example. Next example, example number 4, we are going to multiply polynomial functions. So we're going to say, let's see, we want to find 2x minus 3 times x squared plus 4x plus 3. Now, this is not, this would still be f of g of x, but we're just doing it what we would call a naked problem without the fancy stuff here. Now, the way we're going to do this is we are going to use double distribution, an extended FOIL method to solve this problem. The thing about that is that it's going to end up with, if you look at the number of terms in each set of parentheses and you multiply them together, that's going to give you how many terms. So this one has 1, 2, this has 1, 2, 3, 2 times 3 means that we're going to have 6 things in a line, and then we're going to see if we can combine any like terms. Now, when these get very large, sometimes they can be a huge number of terms, and then we would need to pay more attention to checking our answers and maybe organize ourselves a bit better, which we'll do in a little bit later. So here, I'm just going to rewrite the question so I have a little bit more room to work down here. Okay, times x squared plus 4x plus 3. The key here is to keep yourself organized. I draw arrows everywhere, all over the place, on all of my questions. I am 39 years old, and I still do that because it still works. So I'm going to take 2x times x squared. 2x times x squared is going to give me 2x to the power of 3. Okay, there's always an imaginary 1 above any regular x. So 1 plus 2 is 3. 2x times 4x. 2 times 4 is 8. X times x is x squared. 2x times 3. 2 times 3 is 6. X times no x is just going to give me a regular old x. So that's the first set. Now I'm going to go on the bottom. Negative 3 times x squared is negative 3x squared. Negative 3 times 4x gives me negative 12x. And negative 3 times positive 3 will give me negative 9. So I have 1, 2, 3, 4, 5, 6 terms, just like I predicted I would. Now what I need to do is go through and see if anything here combines. Do I have any like terms? Well, my 2x cubed does not have an x cubed partner, so that's going to stay as it is. My 8x squared, though, does have a partner. There's a positive 8x squared, and we also have a negative 3x squared. So 8 minus 3 is going to give me 5x squared. My positive x here, my 6x, does also have a partner in negative 12x. 6 minus 12 is going to give me negative 6x. My negative 9 does not have a partner, so it is going to stay by itself. Okay? Now, this should be my solution. We're going to do one more check here. Remember, you're going to take your original setup, put that into y1, take what you think the answer is, and put it into y2. And your tables should be identical. So I'm going to plug this in. 2x minus 3 times x squared plus 4x plus 3. And then I think it should be 2x cubed plus 5x squared minus 6x minus 9. And what I'm looking for is, are the two columns of y's identical? And if you look, 7, 7, 0, 0, negative 9, negative 9, negative 8, etc. My two x columns are identical, which means that I have done the multiplication correctly. All right? So the next thing we're going to talk about is something called conjugates. Okay? This is going to be example 4. Now, conjugate is when you have two binomials. Let's just say, for example, x plus 3 and x minus 3, where the first and last terms in each set of binomials is the same, but the sign has changed. So this one's a plus and this one's a minus. Now, we're going to use double distribution here. X times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. And 3 times negative 3 is negative 9. when we look, let's be conjugates. When we look here for like terms, there are going to be like terms in the center, negative 3x and positive 3x. Now, those are going to cancel out because negative 3 plus 3 is 0, okay? Which leaves me with just x squared minus 9. Now, that is always going to be a pattern. So for example, the pattern then becomes this. When you have a plus b times a minus b, where a and b are equal, meaning a is equal to a and b is equal to b, then you will always end up with a squared minus b squared. So whatever the first thing is squared, x squared, and whatever the second thing is squared, with a minus in between. So for example, if we go to another conjugate that's more complex, for example 2x plus 3 times 2x minus 3, we can use this pattern. 2x and 2x are equal, 3 and 3 are equal, the only thing different are the signs. So we would take the first thing, 2x, and square it, put a minus between, put a 3, and square it. Now here's where we get a little bit tricky, okay? 2x squared, whenever you have things inside of parentheses squared, you're going to square each of the things. So 2 squared is 4, x squared is x squared, and then we have minus 9. So this is how we can do that problem without doing too much extra work. And you can always check it in the calculator by putting this into y1 and this into y2 and seeing if the two tables are identical. Alright, let's take a look at another couple of problems. So here we have example, let's see, this would be example 6. Example 6 is another set of binomials. And this is just regular old double distribution. So 2x times 4x, 2 times 4 is 8, x times x is x squared, 8x squared, 2x times 5, 2 times 5 is 10, x times nothing is plus 10x. 3 times 4, x is plus 12x. And then 3 times 5 is 15. Look for our like terms. 8x squared does not have a partner. 10x and 12x are like terms. 10 plus 12 is 22x. The plus 15 does not have a partner. If we plug this into y1 and we plug this into y2, we should have identical y columns. So we're going to go ahead and check that. (2x plus 3 times 4x plus 5 in the top. In the next one, we're going to put what we think the answer is, 8x squared plus 22x plus 15. Go to our table, and our y columns are identical. Okay, if they're not identical, again, you need to go back and find your answer. Now we're going to move on to using exponents inside or as our function notifiers. Okay, so example 7 is if f of x equals x plus 4, find f of x squared. So here's how that works. This is f of x. We want to square it. So what this question is asking us to do is this: x plus 4 squared. Now, what does it mean to square something? To square something means to multiply by itself. What it does not mean is to square the first thing and the last thing. That is not what it means. This is equal to saying x plus 4 times x plus 4. This step is crucial. You have to separate them out and put 2. If it was cubed, you would put 3 of them. If it was to the power of 4, you would put 4 of them. Luckily, we're only going to be doing 2's here. Okay, so we're going to take this x plus 4 times x plus 4 and use double distribution to multiply them out. X times x is x squared, x times 4, 4x. On the bottom, 4 times x is 4x, 4 times 4 is 16. Then we are going to look for like terms. X squared does not have a partner, so it's going to go ahead and move on down. Plus 4x and plus 4x do have partners. That becomes 8x. 16 does not have a partner, so 16 comes down. Now again, you can do this and check your answers. What I don't want you to do is check your answers with work you've done halfway through. You want to start off with the first thing you wrote as y1 and what you think the answer is as y2. If you try and pick something halfway through, then if you messed up on one of these interim steps, then you're never going to find the correct set of answers. So we're going to go ahead and check this one. X plus 4 squared and x squared plus 8x plus 16. Go to our tables, and our two y columns are identical, which means we've done the problem correctly. Okay? Now, for number 11, or sorry, number 8 in our case. Example number 8 is going to be to find x minus 3 squared. So, what's the first thing we need to do? Well, the first thing we need to do is to split it up into two binomials to make this x minus 3 times x minus 3. Then we would use our double distribution to find our answer. X times x gives me x squared. X times negative 3, negative 3x. Negative 3 times x, negative 3x. And negative 3 times negative 3 is positive 9. Look for my like terms. Here they are in the center. X squared, negative 3x minus 3 is negative 6x, positive 9. There is my answer. Do not take this and try and say, oh, x squared and then 3 squared is 9. Those are parts of the answer, but you will miss the center part. Okay? It's very important to make sure that you get that. Now, we're going to do 2 more examples here just to make sure that you see something a little bit more difficult than you might normally see. Alright, so here's our second to last example. This is number 9, I believe. Example 9. We're going to say x plus 3 times 3x to the power of 4 plus 2x cubed minus x squared. Now this is kind of like we did a second ago, except now we've got 2 terms here and 3 terms here, just like we did a few minutes ago with example number 3. Okay? So we are going to first distribute this x to each of the terms in the second one. So x times 3x to the 4th is 3x to the power of 5. X times 2x cubed is 2x to the power of 4. Right? Remember, because there's a 1 here. So we'd add 1 plus 4, 5, 1 plus 3 is 4, 1 plus 2 will be negative x to the 3rd. Then we're going to distribute the 3 to everything. 3 times 3x to the 4th is 9x to the 4th. 3 times 2x cubed is 6x cubed. And 3 times negative x squared, negative 3x squared. Now we look for like terms. All of our numbers are mostly in order from biggest exponent. The 3x to the fifth does not have a partner, so it's just going to jump on down. 2x to the fourth does have a partner. Here's my positive 2x to the fourth. Here's my positive 9x to the fourth. 2 plus 9 is going to give me 11x to the fourth. My negative x to the third also has a partner. 6x to the third. That's going to give me 5x to the third. My minus 3x squared does not have a partner, so that's going to stay as it was. This is one where you have a whole bunch of things. All of our exponents are different, which means we have no more like terms, but with this much math, you definitely want to go and check your answer. So I'm going to plug it in as it started. X plus 3 times 3x to the power of 4 plus 2x to the power of 3 minus x squared. On the second row, I'm going to put what I believe my final answer is. 3x to the power of 5, 11x to the power of 4. Oops, I forgot to put the plus. That would have been bad. Plus 11x to the power of 4 plus 5x to the power of 3 minus 3x squared, and check my tables. And again, my y columns are identical. If these were incorrect, that wouldn't match up. Okay, that is your first lesson. Now I'm going to add on some other lessons from the internet, from YouTube, that I think are good. Obviously, I recommend mine first. But if you're having trouble or you see a problem that you can't quite figure out, feel free to watch the other videos I've attached to this lesson.